All right, class, today we're doing linear functions and models. This is 2.1. So the first thing that we're going to talk about is slope-intercept form, which we actually kind of already talked about in our review. So y equals mx plus b should look very familiar to you. M is our slope, which is also known as our rate of change. And that, if you remember correctly, is rise over run. These are all the same thing. Another thing we can say is it's y2 minus y1 over x2 minus x1. These are all slopes. Okay. The other thing we have here is the letter b. B is the y-intercept, which is also known as the starting point on the y-axis. Okay, so let's start graphing some of these. So the first thing you should do is identify your b value if it's in slope-intercept form. And you know it's in slope-intercept form because it's set equal to y. So there's my b value, which means on the y-axis I start at -3. Then I go, oh, my slope is 2 over 1, which means I go up 2 and over 1, up 2 over 1, and then you can keep doing that and get all the points you need, and you can do the reverse, down 2 and left 1, and there's our line. I like to draw as many points as possible to make a more accurate line. Remember, one thing that I wanted to write up here that I forgot about actually is that the slope, when it's positive, it increases from left to right. And then obviously it's the opposite when it's negative. Alright, so anyway, you can pause the video and write that down. On this one, there is no y-intercept. Well, there is, it's 0, right? So we're going to start at 0. And then we have a slope of -1 over 3, which means now we're going to be going to the right and down. Down 1 over 3. Down 1 over 3, and so on and so forth. Or the reverse, which is up and to the left 3. And then you can draw your nice line going through all the points. And that is how you graph slope-intercept. You find the intercept, you use the slope to find your next points, and you've got it. Alright, to figure out if a function is linear, it must have a constant change in y for a constant change in x. So let's look at what that means. If I look at how this is changing, between 4 and 1, it's going down 3. Between 1 and -2, it's going down 3. 2 and -5, it's going down 3. And 5 and -8, -5, -8 I should say, is -3. And then for the x's, hopefully you guys realize that they're going up +1 each time. So for every movement in the x, we go down in the y3. So this is definitely linear, and we can come up with a function for this. Hopefully you guys see that this table has the y-intercept, so our b value equals 2. I should say -2. And the slope is, remember, just the change in y over the change in x. So since we already did that, it's the y1 over the x1. So the slope is equal to -3 over 1. So I have a function that's y equals -3x minus 2. These points come from that line. Now you can only do that if there's that constant change though. So let's look at this one. This one's going up by 1/2. This one goes up by 1/2. And actually that's a lie. The first one went up by 1/4, if I could do my math there. This one's going up by 1/2. Between 1 and 2 goes up by 1, and 2 and 4 goes up by 2. And right away you guys should see that these are all going up by 1s again. So this is not linear. And then we don't have to do anything else with that, because it's not linear. All right, let's go on. Given these functions, let's find a few different things. Now, remember, this is saying like your y is equal to 0 for this function right here. So the left side will be 0, and we set that equal to, we want to know when this function equals 0. So then we just solve, and you should get that x is equal to 5/2. Okay? So basically you're just setting up the problem as written. Where you see f of x, you put f of x. So 4x minus 1 is greater than or equal to 0. Move the 1 over by adding. You get 4x is greater than or equal to 1. Remember, with inequalities, you have to make sure that you're not dividing by a negative. If you were, you'd have to flip the symbol. But since we did not, we are good with x being greater than or equal to 1/4. Finally, we set this one up. It's saying that I want to know when 4x minus 1 is less than negative 2x plus 5. I'll move the x this way, so I get 6x. I'll add 1 over here. Is less than, this becomes a 6. So it's when x is less than 1. All right. So that's how you set those up. Just put in the function on the where they are and then solve for x. Now we're going to do the same thing for this graph. This is saying when is y lower than 0, which means here's the line y equals 0. So for what x values is the line less than 0? Well, wouldn't you guys agree that that goes down forever? So I would say from negative infinity up until an x value of 5. And I am not going to include that 5 because at 5 it is 0, which we do not want. All right, and now it's saying when is x equal to 0? So we already know, when is y equal to 0? We already know that's at 5. And that's going to be a bracket this time because it's saying equal. And then when does it go up to 10? Well, it goes up to 10 when x is 15. And we do not include the 15 because it does not want you to include the 10. Okay, so that's playing around with linear functions. And then I will get the next video for you guys shortly.